At University Campus, you come at sustainability from a million different ways. Colorado State is been deemed by the Association for the Advancement of Sustainability in Higher Ed, otherwise known as ASHE, has deemed CSU the top research institution in the country for sustainability. And what does that mean? That means we've been doing a lot in the area of academics and research, and we're teaching future, citizens of the world how to have a better planet. We also have engagement and social justice and more efficient buildings and solar panels on our building. It's all those things, and you can't get to be the top of the heap without doing all of it. You can't just say, oh, I've got solar on a few of my buildings, therefore I'm sustainable. It's a lot deeper than that. It's a lot broader than that.
From the beginning of this project, we knew it was going to be difficult. I guess from a project manager's perspective, it was trying to iron it out and make it go as smooth as possible. I mean, we were ripping stuff apart in every portion of this building, which we were literally in every single room of this building, either running piping, changing out coils. I mean, this was basically a showcase project for the university to really showcase where we're at now with 6-pipe heat pump systems. This building is like the pinnacle of what they have on campus, sustainability-wise.
So this project was actually a design-build project. We originally saw it, and we actually approached Adolphson and Peterson, the general contractor, and asked them to truly partner with us. And then A&P and US Engineering, along with our electrical partner, and we selected the Ballard Group to do the design. The Ballard Group selected Geoenergy Services to do the geofield design. We brought that entire team to the interview process with A&P to interview with CSU. One of the really cool things is after we won the job, because of our mechanical expertise and our ability to integrate with the Ballard Group and the design team itself, we were able to steer the design from day one, keeping budget into consideration, reducing the amount of rework, and we were able to get our field crews out here from day one to investigate real-world situations and incorporate those solutions straight into the design itself. So obviously, with this being a geothermal heat pump project, we were trying to take it off of the existing campus steam loop, improve the overall environment of the space, and the geosystem was a perfect fit for us. It allowed us to actually do heating and cooling in the building while also delivering a great project.
The Moby Arena is almost a 400,000 square foot building, and it used to be heated with steam and cooled with air-cooled chiller. Very old, inefficient systems. The steam pipes that serve this building were aging, so we were able to retire the steam, not just to this building, but to this whole side of campus. Replace it with a ground source heat pump. That ground source heat pump now also replaced those air-cooled chillers, and so we get heating and cooling for a fraction of the energy that we used to. We've been modeling this building since we converted to the ground source heat pump, and it's using less than half the energy it was before we started.
I think the geofield is the big part of it. It's this huge renewable energy that's not going to go away.
US Engineering was a partner on this Moby project and did a great job of, not only did we put in a ground source field where we put in hundreds of wells and 70 miles of pipe, but we did miles of pipe inside this building. I don't know if we quite hit miles, but hundreds and hundreds of feet of pipe inside this building to re-pipe this building for this new system. And they were always a good partner in terms of, this is a challenging building. It's like, oh, we got a basketball game tonight. All work has to stop, and oh, by the way, all the systems have to work because we're gonna have 8,000 people in the arena cheering on the basketball team. So they were a great partner in that, in terms of pulling off a good project in a tricky building.
We live in a world that has a limited amount of resources, and trying to be mindful and responsible with all the resources that we use on a day-to-day basis. And if there's any way that we can make that better, and not only can we make it better, but we could, in this case, save CSU 50% of their energy costs while doing it. And the payback makes this a completely worthwhile project for CSU.